In this video, we'll be exploring covariance and correlation. These two measures can describe relationships between two variables. So, for example, maybe we want to know to what extent are education and income related, or to what extent are poverty and criminal behavior related. So when we're looking at covariance and correlation, we want to ask ourselves two questions. Are these two variables related? In other words, are they dependent or are they independent? And if they are related, how can we characterize and describe the strength and direction of this relationship? One way that we can kind of start to see if two variables are correlated are scatter plots. And these are graphs that just plot the values of x with the corresponding values of y. So in this graph here, we can see that we've got average daily temperature and number of beach visitors graphed. And we can see that these values are pretty highly correlated, although not all the values are perfectly consistent with the general direction of the relationship. This brings us to covariance. The formulas for variance and covariance are very similar, as you can see. And the way that we want to interpret covariance is, if the covariance between x and y is greater than 0, the two variables are positively related, meaning that as one variable increases, the other variable will also increase, or as one variable decreases, the other will also decrease. A positive relationship indicates that both the variables move in the same direction. If the covariance is less than 0, so if you have a negative value, this means that the two variables are negatively related. Now, take note that this doesn't mean that the variables just decrease at the same time. What negative relation refers to is that the variables move in opposite directions. As one goes up, the other goes down. Finally, if our covariance of x and y is 0, it means that the two variables are unrelated. There is no covariance. So, moving from covariance to correlation. Covariance can be really sensitive to outliers and to scaling. And correlation can adjust the covariance to be unaffected by scaling, because correlation is the standardized measure of a relationship between two variables. And the formula for correlation is as follows. We can deal with the sensitivity of the covariance by scaling it by the standard deviation of each of the variables. Another note about correlation is that all correlation values fall between -1 and 1. And this little handy chart on the right here shows you the general interpretation of correlation values between two variables. As a final note in this little stats video, I will leave you with this. Correlation does not imply causation, and that's one of the most important things to remember when you're doing any kind of statistical testing. Correlation does not mean that one variable causes another, right? And there can be a lot of different reasons for this, but usually it's because there's a third variable kind of hidden in there that's affecting the two variables that are highly correlated. For example, the amount of shark attacks and the amount of ice cream sales both increase exponentially in the summer. Shark attacks and ice cream sales are two very highly correlated variables, and if we were to graph these, it would look like ice cream sales actually drive shark attacks. But that can't really be true, right? Does eating ice cream make you more likely to be attacked by a shark? Not really. What's really happening here is that there's kind of a hidden third variable coming into play, and that is the summertime. Ice cream sales and shark attacks both increase around the same time of year in the summer season, and that's because more people are going to the beach and swimming in the ocean in the summer, and also more people are eating ice cream because the temperature's hotter. This hidden kind of third variable of it being summer and the temperature being hotter affects both ice cream sales and shark attacks, making them look like they're highly correlated and maybe even related, when in reality they aren't really actually affecting one another.